Hi, welcome to Sujata Math Solutions. Today's topic quadratic equations. In quadratic equation, we're going to learn about a solution by quadratic formula. Already we have completed two methods, right? This is the third method. Here, what is the quadratic equation? Ax square plus bx plus equal to 0 is the quadratic equation. Quadratic formula defines the roots as x equal to minus b plus or minus square root of b square minus 4ac by 2a. Right. Here, in these two roots, what is the roots of quadratic equation? Alpha, beta are roots of quadratic equation. Right. Here it has a two roots. So one is we have to take alpha, beta are roots of quadratic equation. So alpha equal to minus b. One is plus, one is minus. We have to write that. Minus b plus square root of b square minus 4ac by 2a. And second root beta equal to minus b plus over next minus square root of b square minus 4ac by 2a. These two are roots of quadratic equation. Right. Next, here b square minus 4ac is a discriminant of quadratic equation. So here b square minus discriminant we have to denote it dr delta. This is a delta as a triangle. Yes or no? So we have to denote dr delta. So that d equal to b square minus 4ac by 2. Here b square minus 4ac. The b square minus 4ac, it is the discriminant of the quadratic equation. Okay. Next, sum of the roots. These are the two roots. Yes or no? So sum of the roots alpha plus beta equal to minus b by a. Here minus b by a, minus b is a coefficient of x. B is coefficient of x and a is coefficient of x square. Okay, so that here minus b minus coefficient of x by coefficient of x square. Next, product of the roots. Right. What are the products of the roots? Alpha, beta equal to c by a. Here c is a constant term and a is coefficient of x square. Now let us prove this sum of the roots minus b by a. Right. Here what is that? Sum of the roots alpha plus beta equal to minus b by a. So here what is the alpha? Minus b plus square root of b square minus 4ac by 2a. So that alpha plus beta equal to minus b plus square root of b square minus 4ac by 2a plus next root minus b minus square root of b square minus 4ac by 2a. Right. Here alpha plus beta, this is the alpha and beta. Now we add there here. Minus b plus square root of b square minus 4ac by 2a. Next, plus into minus. So, minus, already denominators are equal. Yes or no? So, just compare the numerators only. Here plus into minus, minus b. Next, here also minus. Plus into minus. Square root of b square minus 4ac. Now see, plus b square minus 4ac plus b square minus b, both will get cancelled. Then what is left over? Minus b. Minus b here, that is equal to minus 2b. Why? Because same sign we need to add. And the sign should be carried by 2a. 2 cancel minus b by a. Here minus b by a means b is a coefficient of x. Already here minus, so that minus coefficient of x by a is a coefficient of x square. Coefficient of x square. So that hence it is proved. Sum of the roots alpha plus beta equal to minus b by a. So that here when we are doing, it is the minus b by a. Hence it is proved. Next one is the product of the roots. Product of the roots here alpha beta. Alpha beta equal to here minus b plus square root of b square minus 4ac by 2a into beta is minus b minus square root of b square minus 4ac by 2a. Okay, now here check it there. Here this is a plus b into a minus b formation here. So that here a plus b into a minus b equal to a square minus b square. So that here we have to write in this formation. Right. What is a? A equal to minus b and b equal to square root of b square minus 4ac. We need to substitute this. Right. That is equal a square minus b square. A means minus b by 2a. Here by denominator 2a is there. 2a whole square minus b square. B square means what is that? B square root of b square minus 4ac by 2a whole square. Now that is equal to minus b square only. Here minus also when you are squaring plus. So b square by 2a whole square. 2a whole square, 2 square means 4. A square means a square means a square. Next minus here square root to cancel, and here exponential form a by b whole square means a square by b square. So that square comes under a 2a whole square also. Here when you are squaring b square minus 4ac, root to square root cancel. Then here 2a square means it is 4a square. 2 2s are 4 and a square is square. So that here right, b square minus 4ac by 4a square. 2a square means 4a square. Right. Now here same denominator you need to add their numerators. So b square, here minus b into plus b minus b square minus into minus plus 4ac by same denominator 4a square. Okay, plus b square minus b square both will get cancelled. So 4ac by 4a square. We have to split this 4a into c by 4a into a. A square can write a into a. So here 4a cancel. C by a. C by a means here c is a constant term and a is coefficient of x square. Next, formation of quadratic equation. Already alpha betas are roots of quadratic equation. Then sum of the roots. Alpha plus beta equal to, already we know, minus b by a, and product of the roots alpha beta equal to c by a. When they are giving sum of the roots, product of the roots, we need to form the equation. So here what is the quadratic equation? Ax square plus bx plus c equal to 0 and a not equal to 0. Okay, here x square coefficient must be 1. So what we have to do here? We need to divide the coefficient of x by all terms of the equation. So a x square by x square a plus bx by a plus c by a. Why? Because coefficient x coefficient will be 1. So a cancel, then x square plus b by ax plus c by a. Now we have to replace b by a at alpha plus beta, c by a at product of the roots alpha beta. Now see, x square plus minus here b by a, already here minus b by a. So that we have to plus as minus. Why? Because here alpha plus beta, b by a is negative side. So alpha plus beta into x. Next plus c by a. C by a means alpha beta equal to 0. Then here this is the formation of equation. Here alpha betas are sum of the roots and alpha beta are product of the roots. So that x square minus sum of the roots into x plus alpha betas are product of the roots. Product of the roots equal to 0. When they are giving sum of the roots and product of the roots, we have to form the equation by using x coefficient must be 1. Right. Next one. One is nature of the roots. Nature of the roots of quadratic equation. Nature of the roots of quadratic equation depends on the discriminant of discriminant. Nature of the roots of the quadratic equation depends the discriminant. Here what is the discriminant, delta or d? So that delta equal to b square minus 4ac. Here the value of b square minus 4ac defines the nature of the root. So here what are the natures? We have to see. First one, delta greater than 0 and delta equal to 0, delta less than 0. Then what is the nature we have to do now? Now here ABC are real numbers. Then the roots are real numbers. Then the roots are. First one, what is that? Delta greater than 0. Delta greater than 0 here. For example, we see one example. X square minus 3x. X square minus 3x plus 2 equal to 0. This is the quadratic equation. Okay. When the delta greater than 0, then the roots are real and distinct. So now see, delta equal to, here a equal to x coefficient is a 1, y b coefficient, here x coefficient is minus b and the constant term c is 2. Next, here now delta equal to b square minus 4ac. Here b square is minus 3 whole square minus 4 into a is 1 and c is 2. That is equal to delta equal to 3 3s are 9 minus 8 equal to 1. 1 is greater than 0. So that here 1 is greater than 0, then the roots are real and distinct. Roots are real and distinct. Right. Next one. Delta equal to 0. Delta equal to 0, here roots are real and equal. Roots are real and equal. Now let us see one more example here. For example, x square minus 4x plus 4 equal to 0. Okay, this is the, for example, I have taken the quadratic equation. Now see here, x coefficient is a, x coefficient is b, here b is minus 4 and the constant term is c. Now discriminant delta equal to b square. B square means b is minus 4. So minus 4 whole square minus 4 into 4 AC. A is 1 and C is 4. That is equal, delta equal to 4 4s are 16 minus 4 4s are 16. Okay. So 16 minus 16 equal to 0. Therefore, delta equal to 0. When the delta equal to 0, the roots are real and equal. Now let us see for roots also. Here, x square minus 4x plus 4. We have to find the factors here. So x square, 4 factors 2 into 2. Okay, here 2 into 2, when you are adding this both to minus 4x equal to middle term. So here it has a negative sign. So that here we have to use sign also, factors minus 2 minus 2. Now see here, minus 2x plus 4 equal to 0. Now we have to take the common, x minus, x taken common, x square means x minus 2. Here minus 2 you have to take the common. Then x 1 to 2 and 2 2s are 4 minus 2 equal to 0. Then x minus 2 and x minus 2 equal to 0. Then x equal to 2 and 2. So roots are, so here roots are 2 and 2. And parabola also, if you see the parabola, roots are equal. So here it is touches the x-axis. And also roots parabola we have to show like this also, and it will becomes touches the x-axis. And when the greater than 0, also it is parabola touches the two distinct points on x-axis and we have to use like this also parabola. Okay. Next delta less than 0. Delta less than 0, here roots are non-real, complex and conjugate to each other. So let us see here one example. X square plus 2x plus 3 equal to 0. Okay. Now discriminant delta equal to b square minus 4ac. Yes or no? So here a equal to x coefficient 1, b equal to y coefficient 2, c equal to constant term 3. Now delta equal to b square minus 4ac. So b square means 2 square minus 4 into 4ac. A is always coefficient 1 only. So c is 3. That is equal, delta equal to 2 2s are 4 minus 3 4s are 12. That is equal to minus 8. So here delta equal to minus 8. It is less than 0. So that non-real. This is a non-real, and here roots are complex and conjugate to each other. So here alpha plus or minus I beta. Next ABC are rational numbers, then the roots are. Okay. Same here, delta greater than 0. Here we have two conditions. In delta greater than 0 and is perfect square, then it is the rational and distinct. So for example, we see one example. X square minus 5x plus 4 equal to 0. I have taken one example. Okay. So here we have two conditions, delta greater than 0 and as perfect square that it is roots are rational and distinct. So that all we have to prove it now. So this is the quadratic equation. In the quadratic equation, a equal to x coefficient 1, b equal to x coefficient minus 5, c is constant term 4. Right. Now, delta equal to b square minus 4ac. b square means minus 5 whole square minus 4 into 4 equal to 0. Then 4. Next, 5 5s are 25 and minus 4 4s are 16 equal to 25 minus 16, 9. 9 is square of 3. So that 9 is perfect square of 3. So that when the delta greater than here, it is greater than 0. Delta greater than 0 and it is perfect square, then the roots are rational and distinct. Okay. Next, same condition, delta greater than 0 is not perfect square, then the roots are not rational number, they are complex numbers. That also we see one example. I will take here x square plus 3x, x square plus 3x minus 2 equal to 0. So now check it there here also. A equal to x coefficient, b is x coefficient 3, c is a constant term minus 2. Let us check it now. Delta equal to b square. B square is b is 3. So 3 square minus 4 into 4 ac. C means minus 2. That is equal to delta equal to 3 3s are 9. Here 4 2s are 8. Minus into minus plus. So that plus 4 2s are 8. Here 17. Delta equal to 17. It is not a perfect square. 17 is not a perfect square of any number. So that here roots are irrational and conjugate to each other. So that alpha plus or minus beta roots are irrational and conjugate to each other. Next one, delta equal to 0. Delta equal to 0. Delta, when the delta equal to 0, roots are rational and equal. Let us see one example. Here x square minus 2x plus 1 equal to 0. Okay. For example, I have taken this equation. Right. Here x coefficient is 1. X coefficient is minus 2b and constant term is 1. Now, delta equal to b square minus 4ac. This is the discriminant. Okay. Here, b square means minus 2 whole square. Okay. Minus 4 into 1. That is equal to 2 2s are 4 minus 4 equal to 0. Therefore, delta equal to 0. When the delta equal to 0, roots are rational and equal. Next one is delta less than 0. Here delta less than 0, actually roots are imaginary and conjugate to each other. Now one example I have taken 2x square. Now I will drop this 2x square. Two x square minus 3x plus 2 equal to 0. Okay, when delta less than 0. So now here roots are imaginary and conjugate to each other. Now here x coefficient a 2 and x coefficient b minus 3 and constant term 2. Now delta equal to b square means minus 3 whole square minus 4 into a here 2, b here 2, A and B both are same, equal to 0. That is equal delta equal to 3 3s are 9 minus 2 4 2s are 8, 8 2s are 16 minus 16. Here what is that? 17 9 minus 16. 9 minus 16 is how much here? 7 minus 7. Here minus 7 is these are not a rational number. Here these are imaginary. Roots are imaginary numbers. Imaginary and conjugate to each other. Okay friends, this is quadratic equations, very important chapter. So this is very useful, and also I will make important questions. Next to 10th class we are going to write 100 marks. So each chapter I will give important questions. Now I am giving introduction and some examples also I have given. Next videos I will make important questions. Okay, important questions I will frame, and I will give the all solutions of the important question. So that watch everyone, and please say, share, subscribe my channel. Thank you so much.